Okay, so we start the review of thermodynamics, no? So let's start with the review of thermodynamics. Thermodynamics. Okay. So the word thermo, so which means therme. So that will be therme. So that means that is heat. Okay. Then dynamics is the movement. Okay, so that is the movement of heat. Okay, so that is the term in thermodynamics natin. Then we have branch of physics. So we have branch of physics, so which deals with heat and transformation, and deals with heat, so that will be and its transformation, its transformation. Okay, so we have call it one. So the types, so we have the types of thermo, that will be, so one, we have the classical thermo. So classical thermo, so deals with the microscopic. Thermodynamics that deals with the macroscopic macro, so that deals with macro, so which means that is bigger than the atom. Okay, so what should we be dealing, no? Then we have another one, which is yung statistical thermo. So that will be thermodynamics. So thermodynamics that deals with microscopic, micro. So that is the atomic structures na ito siya, usually. Atomic structures. Okay. Then we have the definition of matter. Okay, let's pause this one first. We have the definition of matter. So matter, that will be anything, so that defined as anything that occupy or occupy or occupies a space and has a weight. So, okay. Then we have the properties of matter. So properties of matter. So we have two properties. So one, we have intensive properties. So this is not additive. So this is defined as not additive. So this is not additive within matter, and it is mass independent. So sample are, so we have pressure, and then we have temperature, which is not also independent in mass. Temperature, then we have also specific properties. So properties, which is divided by where specific properties where properties divided, so properties that is divided by its own mass. Okay. Then next we have extensive properties. So this is additive within matter. So this additive, so kanina we have additive within matter, and it is mass dependent. Okay. So sample niyan, we have mass, okay, we have volume, then we have weight, no? So those were the example. Then so let's define the extensive properties, no? Let's define the extensive properties that we have. So let's start with the mass weight relationship. Now we have the mass and weight relationship. So we have your weight, usually that will be equal to mass times the gravity. So for the units, we have your English, so that will be USCS, customerization. So we have the unit of slug, feet, second squared, or that will be pound force. And for the metric MKS, we have also Hill meter second squared, or it will be kilopound of, it is kilogram force. Then we have your SI, so this will be kilogram meter second squared. So that will be, or it is defined as Newton. Okay. Then for gravity, so our gravity, so that will be the unit of also of feet second squared. Then we have for MKS meter second squared. For SI, we have feet meter second squared. So we have your local gravity. So we have 32.2 feet second squared, and then we have 9.81 meter second squared. Then okay, so we have the definition of that one. So we have the conversion of 1 kilogram force is equal to 9.81 Newton, which is equal to 2.206 pound force. So we have that conversion. So take note of that one. You will be needed when you're taking your board exam. Okay. So the basic laws, we have the basic laws governing mass. So we have your one, the Newton's statement on mass. Newton's statement on mass. So he defined it as, his statement was anywhere in the universe given mass is constant. So anywhere in universe so given mass is constant. Given mass is constant. Okay, so that defines the Newton's law, Newton's statement on that one. But we call this, for example, one of the basic example nito, we have here, if you are in, for example, if we have a weighing scale, no? Okay. So we have your weighing scale, then you have here the bodies of maybe 1 kilogram mass. Okay, so this is 1 kilogram mass. Now if you are in Earth, okay, so that is acted by the gravity, which is 9.81 Newton. Okay, so that is yung 1 kilogram force, that will be equal to 1 kilogram force. So pag nandito ka sa Earth, that is 1 kilogram force. That is 1 kilogram mass. That is on Earth, no? Where you are in the latitude of 45 degrees. So at the gravity observed is equal to your gravity standard, no? Now, if you are in the moon, okay, if you are in the moon surface, okay, so that will be 1/6. So the gravity is 9.81 Newton divided by 6. That is 1/6 of the Earth's gravity. 1/6. So that will be yung weight mo, the reading of the we call this weighing scale. The reading of the weighing scale will be 1/6 kilogram force. So because of the gravity is already 1/6 of the gravity of the Earth's gravity, where your gravity observed will be equal to 1/6 of the gravity standard. So where your gravity standard, that will be 9.81 meters squared. Now if you are in the Jupiter surface, no, so we have your gravity observed, that will be 12 times the gravity standard or gravity on the surface. So that will be 12 times ng value ng ano. So the weight mo usually will be 12 kilogram force. So yun ang pinagkaiba na when you are, so that's why Newton's statement defined is that anywhere in the universe the given mass is constant. So what varies now is yung gravity ng surface of the places or surface of the Earth or surface of the planet, that which is acted, but the mass will be constant. Then we have the Einstein statement. On mass. So he defined as you have your mass MO, that will be is equal to this we have sorry, let's change this one. So we have your mass, so that will be equal to mass is equal to the square root of 1 minus b squared over your c squared, where this is the observed mass natin siya. This is the observed mass, where your v defined as the speed of the object. Okay. Then your c is the speed of light. Speed of light. Okay, so that this is equal to 186,000 miles per second. So that is an equivalent to 300,000 kilometer per second. Okay, so that defines the Einstein statement on mass. That mass is the mass observed is inversely proportional with your mass, then divided by the square root of b squared over c squared, or the velocity, the speed of light. Then we have another. So number 3, that will be the law of conservation of mass. Law of conservation of mass. So law of conservation of mass, so it is defined as mass cannot be created, cannot be created nor be destroyed. So unless a nuclear process occurred, unless nuclear process occurred, no? So that defines the law of conservation of mass. So where your mass entering is equal to the change of mass plus the mass leaving the system. Okay? Or it can be defined as the mass in, that will be is equal to the change in mass plus the mass out. Okay? So that defines yung law of conservation of mass. So if the mass is annihilated, no? Annihilated or destroyed, completely, so we have then the Einstein's mass energy is observed. So that is the equation of E is equal to m mass times the c squared. Okay. So that is for the mass. So let's go to the intensive properties. So for the intensity properties, so let's start with the mass density, no? So we have your mass density. So take note, this is a review na lang, no? So we have your symbol of this one, which is the rho. Okay. So that it defines as, the definition is, that will be the mass per unit volume. Mass per unit volume. So we have here, okay. So we have your mass and this is the volume. Okay. So we have your weight acting here. So we have now your density is equal to the mass over the volume. So that will be the equation of that one. No? Where for your units on English, so that will be slug per cubic feet, or this will be pound mass per cubic feet. So take note volume, no? So you will be aware. So kung nag-iba na ng yan ng unit, so that means there is something wrong with the properties, especially pag nagko-compute tayo, no? So yun yung one of the advantages of knowing the unit is you can check if the equation is correct. One of the way, no, not totally for check, but one of the way for checking na the equation is right or wrong, or your solution was right or wrong, by means of checking the units, the cancellation of units. So that is very important. Then in MKS we have your Hill cubic meter. Then we have your kilogram mass per cubic meter. Then we have kilogram mass per liter. Now for the SI units, so we have your kilogram cubic meter. Okay, so that defines. Now I have here the conversion, no? So one slug So that will be 32.174 pound mass. So that defines the slug, the conversion. So, but it is also a form of mass, yung slug. So, but in call this in plant engineering, so mostly ang ginagamit is mass or pound mass and kilogram mass yung ginagamit ang value preferred. So this is most preferred use over slug and hill respectively. Okay. So I write down here the common conversion. No? So we have the 1 cubic feet, that will be 7.48 gallon. Then we have your 1 barrel, so that is 42 gallons. So barrel usually yung that is being used by the petroleum storage. No? Then we have your 1 drum, that is equal to 55 gallon. Then we have, this is common, 1 gallon is 3.785 and 1 cubic meter is 1,000 cubic liter. 1,000 liters, sorry. Then next we go to properties of water. So for water, we have at NTP, which is defined as normal temperature and pressure. So water at its greatest density, density will be at the 4 degrees Celsius, so that is equivalent to 39 degrees Fahrenheit, no? So at normal for NTP, mostly yung gagamitin natin, and also in all your engineering problems or plant engineering problems, the mostly density value of water that is being used is equal to, for the English, we have 62 for the English. So we have 62.4, that will be pound mass per cubic feet, and it is equal to 8.33 pound. This will be 8.33 pound mass per gallon, and this is equal to 1,000 kilogram per cubic meter. Okay. So let's erase this one. So this is the common value of your density that will be using again and again for your engineering problems and also for your board exam. Okay. So take note of that one. So let's go to the second specific. No, so second properties we have is specific volume. So we have the symbols na ganito siya. Then sometimes it's called be SP or V. Okay. So where specific volume defines as we have your volume over your mass. Okay. So that is the reciprocate of density. Then the units that will be cubic feet per pound mass, and we have cubic meter per kilogram mass. Okay, so that will be the units, no? So variance, we have a variance of the equation since it is a reciprocate of density. So we have a specific volume that will be can be expressed as mass over the volume. So that is equal, which is equal to 1 over your density. Okay. Then vice versa, also it can be expressed as your density. Can be expressed as density. So it can be expressed as your density, which is 1 over the specific volume. Okay. So that is where the variance of your specific volume and density. Then for number 3 properties, we have specific weight. So specific weight, or sometimes they have defined as weight density. So it is in the symbol, which is gamma. Okay. Then we have your equation, specific weight, that will be weight over the volume. Okay. So for English units, we have, this will be pound force per cubic feet. Okay. Then this is for MKS, it will be kilogram force per cubic meter. For SI, so it will be defined as Newton per cubic meter. Okay, so define this one. And also in English, it can be expressed as pound force per gallon, and this one is kilogram force per liter, or MKS. So we have variant form, no? So we have your variant form, specific weight, that will be weight over volume. So where your weight is expressed as mass times your gravity divided by the volume, where can be if there is other gravity, or let's say the gravity was in moon, so we can express as the mass times the gravity observed divided by the gravity standard. If you are in the moon or in Jupiter, or it can simply as it can be simply as defined as, this is your mass over volume. It can be simply as defined as density times the gravity, that is the variant of the specific weight. Then we have the relative density, or sometimes they call it, very common, call it the specific gravity, Hg, or sometimes it is expressed as Hg, specific gravity of the object. So it is defined as the ratio. So ratio of the weight of a substance with ratio of the weight of the substance, to the weight of an equivalent, weight of an equivalent volume of water. So volume of water. So it is defined as the ratio of weight of the substance to the weight of an equivalent volume of water. So we have for solids and liquids, we have this equation for solids and liquids. So we have your Sg, so of the substance, that will be weight of the substance, then weight of the H2O, or let's say that is the specific weight, call this the specific weight of the substance multiplied by the volume of the substance. Then we have the specific weight of the water, then we have the volume of the water. So if the volume of the substance and volume of the water are equal, so we can cancel out this one. So we have the specific weight of the substance, then specific weight of the water. Now or it can be expressed also as density of the substance, then of your density of the water. So it can be expressed as density of the substance, then density of the water. Okay, so we have the variant for specific weight. Now for specific gravity of a gas. For gas naman, we have the specific gravity of the gas. So that will be equal to the molecular weight of the gas divided the molecular weight of the air. Okay? Where the molecular weight of the air is equal to 29 kilogram per kilogram mole. Okay? So we have kilogram mole. No? Now for oils naman, we have yung for fuel oils. For fuel oils, so we have the standard gravity that is measured by means of degree Bohm, o makita nyo yung symbol, that is B, or we have yung degree API. Okay, so that is from the American Petroleum Institute. American Petroleum Institute. Okay, so institute rating. So we have for standard gravity, no? So at standard gravity, so that will be at 15.6 degrees, or that will be 15.6 degrees H2O, or we have 60 degrees Fahrenheit per 60 degrees Fahrenheit of H2O. So we have the specific gravity of oil, so that will be 140 divided by 130 plus the degree Bohm, or this is in equivalent to 141.5, that is divided by 131.5 plus degree API. Okay. Then for other temperature, so other temperature, so we need to apply the correction factor. So for the correction factor for temperature, so we have the equation which is correction factor that will be 1 is equal minus 0.0007, that is multiplied by degrees Celsius minus the 15.6. Then we have this can be equal to 1 minus also 0.004 times degrees Fahrenheit. If the degrees Fahrenheit is given, then we have 60 degrees. Okay, so that will be the correction factor. So okay, so that defines the specific gravity of oil. So let's go to the intensive properties. Let's go to intensive properties. So we have pressure and temperature. So going to pressure. So we have pressure and temperature. Fundamentals, no? Pressure, temperature, fundamentals. Okay. So we have the definition of temperature. So that is the measure of degree of hotness or coldness of a body. So measure the degree of hotness or coldness of a body. So that is the temperature. So it is the indications of also indications of kinetic and of the kinetic energy of the molecules of the molecules of a substance. So take note, we have NB, nota bene. So that defines the thermodynamics in, take note ito palagi, no? In thermodynamics and plant engineering calculation and plant engineering calculations. So always take note, always we use absolute value. Absolute temperature. So before you substitute it to the problem, or before using it on the not substituting the problem, but before using it to the equation or substituting to the equation, so make sure you convert it to the absolute temperature. So para hindi kayo magkamali. So usually pag substitute nyo na without converting it to absolute, so the answer will always be wrong. Okay, so take note of that one. So maski sa, even though in your board exam, it will be required, or it will always be required, the absolute temperature substituting to the equation before calculating it. So if you will not substitute the absolute, you will automatically get the wrong answer. Okay. Then we have your degrees Fahrenheit. So the equation, we have 1.8 times the degree Celsius plus 32. We have your equation to convert the degree to degrees Fahrenheit. Then also we have your absolute temperature, that for Fahrenheit it will be added by 460 in order to make it Rankine, degree Rankine. Then we have the temperature for Celsius, that will be added by a 273, that in order to make it Kelvin. So we have this following equation. So this is very common. Now it's a form of review, very common to the physics, thermodynamics. Okay. So let's go to pressure. So in pressure, so it is defined as the force, okay, force per unit area, which is normal. It will be normal to the force, where the area is normal, to the force, which is, when you say normal, so that is perpendicular. Okay. So sample here, we'll draw a plane. So usually the pressure will always be, so if you have the plane here, so the pressure will always be normal. Okay. So the force will be always normal to the surface area. So if this is your surface area, so if not, the force, if not normal, so if you have a force acting on this side, so we have your angle, okay, we have your theta. So it can be expressed, for the pressure can be expressed as force normal divided by your area, or it will be force times the cosine of theta divided by your area. So that will be the definition. So take note, nota bene. So in thermodynamic and plant engineering, so in thermodynamic and plant engineering, so calculations always will be using absolute palagi. So absolute pressure. Take note. So before substituting to the equation, yung pressure must be converted into our absolute value. Take note of that one. So that defines. So we have the pressure absolute equation, that will be pressure of the barometer plus the pressure at the gauge. So also P barometer minus the P vacuum. Okay. So we have the equation for the absolute pressure. Now we have also call this standard. We have your 1 atmosphere, which is yung surrounding us. Now so we have value in conversion when UCS, so that will be 34 feet of H2O absolute. Okay, so AB, so that is equal also to 29.92 inch Hg absolute, which is equal to 14.7 psi absolute. Okay, AB. For MKS, so we have 760 mm of Hg absolute, which is also equal to 1.033, that will be kilogram force per square centimeter. That will all be absolute also for SI. So we have 101,325 Newton per square meter. So this will be also absolute. It will be equal to 101.325 kilonewton per square meter. Okay, so take note of that one conversion.